Why is the heat pump freezing up? Today we're at the apartment buildings and we're working on a heat pump and the unit's freezing up. Today I'm going to show you what types of problems I have in the field with these types of units in apartment buildings. You're watching HVAC Tips for Technicians. I'm Tad. Let's get started. Got the call that the equipment's freezing up. That means that in the cooling mode, since this is the heat pump, the indoor coil would freeze during the cooling operation. It's about 40 degrees outside, so I know they're using it in the heating mode, and that means that the outdoor unit is probably freezing. So outdoor unit freezes during the heating operation, indoor unit freezes during the cooling operation if there's not enough refrigerant. And if there's not enough refrigerant, if the outdoor unit does freeze up and there's a bunch of frost, it's not going to defrost unless there's enough refrigerant so that when it goes into defrost operation, it will send hot gas through that outdoor coil and thaw it out. So we got a heat pump, it's freezing up, and we're gonna figure out what's wrong with it. So what do we wanna do? We wanna check the heat pump in the heat mode. And first we need to know what the thermostat's set for. So let's check the thermostat. Thermostat's a little bit hard to get to here. It's in the off position. Let's turn it to heat, 72 in here. I'm gonna turn it to 78. And this is the indoor air handler. Let's get a backup view so you can see it. You can see it's open right there. So behind this filter, you've got the coil. And then behind this panel, you've got the blower. Electrical's up here, and to disconnect the power you've got this plug right here so that you can take this panel off, and until you disconnect this right here, this disconnect, you can't actually access behind this panel. We'll take a look at this, but first we need to take a look at that condenser. And you got to make sure you know which one it is. It is not this one. So what we got here? Here's the condenser. I've got everything set up. And when I got here, disconnect, the breaker was off. So turn it on. You can see it's running. Got the gauges hooked up. Low side, high side's about 225. Low side is going down. Okay. So we're in the heating mode. It's about to cut off. You can hear it pulling down. You hear that sound? 15 PSI, it's about to cut off. There it goes. So low pressure switch is cutting the unit off. It'll kick back on here in a second. It'll try to operate, and of course it's gonna kick back off. Let me show you how my gauges are hooked up. Got the breaker shut off because I don't want the unit to just set and cut on and cut off and cut on and cut off. Obviously it's low on pressure and we're gonna charge it. I'm going to talk to you about how I have the gauges hooked up. So low side gauge goes to the port that goes to the suction line of the compressor. So we're measuring the suction pressure here with our low side hose hooked to our low side gauge. Then this line right here is the hot gas vapor line. And that's why we have our high side hose hooked here. During the cooling operation, when we're trying to measure pressures in the cooling mode, this hose would be hooked here, and then this hose would be hooked here. If you want to learn more about a heat pump in the heating mode and how the refrigerant flows, I have a video on how to charge a heat pump in the heating mode. It's on my members only videos, but I'll drop a link in the description so you can see that, and I explain in that video. So this is how our gauges are hooked up in the heat mode. Got my scales. Need to go ahead and turn my scales on. So of course we are going to charge this system, and what I'm going to do is I'm going to hook my pipe clamp right here on the vapor line because I want to measure that vapor temperature. It should be at least 100 degrees. It should be a lot more than that. You're going to see that as we charge the equipment. Scales are on. Now I'm going to zero it out. Boop. Make sure I bleed it. Okay. Zero it out again if you need. Okay. Meter is on. Now I'm ready to measure the temperature. Okay. Let's turn it on. Let's add some refrigerant. 250 on the high side. All right, we'll go ahead and start adding. You see we're adding 4 ounces. Pressure on the high side, slowly going up. Got 13 ounces, almost a pound. 16 ounces makes a pound. There's 16 ounces, that's 1 pound. We're gonna turn it off. See where we're at. Oh, wow. Must be really low. Either that or we have a restriction. I'm gonna add some more. See what happens. I'm going to change the units to 1 pound, now almost 2 pounds. Paying attention to the high side, it's 275 now. Let's go ahead and turn it off. We got 2 pounds in it. Okay. $275, so it's staying steady right there. I'm going to go ahead and add a little more. What's our temperature? Temperature of the vapor line is 105 degrees. So this line now is 105 degrees. Ooh, feels warm. But we're still pumping down. Almost. I'm going to add a little more. See what this system holds. So, looks like our system holds 12 degrees of subcooling on the indoor TXV. 6 pounds is what the system holds. 5.95 pounds. And we've added 3 pounds of refrigerant now. 3 pounds, 2 ounces. Pressure is 45 and 300. Temperature on the vapor line is 114. This is a 24,000 BTU unit. So 25 HBC 324. So it's a 2-ton unit. It's got a piston. And where's that piston metering device? Right here. Okay. It's got a filter dryer. You need to check across it, make sure there's no temperature difference from one side to the other. That way we don't have a restriction. It looks like it was just low with refrigerant so far. So, 116. 3 pounds, that's pretty low. We definitely have a leak. So, and it's probably in the indoor coil. But before I check the indoor coil, I'll actually get the breaker, turn it off, and then I'll pop the top and look inside. So you do not want to rule out the condensing section without looking. So you need to look at everything. Observation is your best telltale sign. And once you've looked, you need to get your leak detector. If you don't know how to check for a refrigerant leak or find one, I've got a video on that. I'll drop a link in the description. So, okay, awesome. 121 degrees on that vapor line. Let's go inside and check the temperature split. Got the probe inside the supply vent, and this is a dual In-Duct psychrometer. It says it's 141 degrees, and I know that's not just the heat pump. We have those heaters, the heat strips are running as well. So you want the true reading of just the heat pump. You want to make sure it's over 20 degree or at least a 20 degree split. You need to disconnect the heat strips, and I've got a video on that. So I'll drop that in the link in the description, but it's definitely heating. Let's check out that indoor air handler. before we do that, 132 degree on the vapor line. High side is 325, 330. Low side is about 55, 60. Okay. Okay, so here is the air handler. 1/3 horsepower motor inside. And got a couple heat kits to choose from, but we don't know which one's in there. So here's the disconnect. And now that we've got that removed, we can take, and I'll pick that up in a second. It's hard to hold a camera and take apart this unit, let alone keeping the screws. Oh, duct board. Nice. Okay. So we got an X13 motor. And these go bad. Sometimes they'll go back and forth. That's how you know they're bad. Sometimes they won't run and they have power. And sometimes they'll run all the time. So what else to have go bad? Sometimes this relay right here will go bad. And this relay not only controls the heaters, but it controls the motor as well. So some of these apartments have sequencers, some of them have relays like this, and that sequencer will go bad. You'll have the unit in the cooling mode, but the indoor fan won't be running, and that'll cause the indoor coil here to freeze up. You can tell we got some major rust, and I would not be surprised if this coil is leaking. Drains got to have good maintenance. Some of these apartments do not have good maintenance, and because of that, you will have these drains that are stopped up. You can put a shop vac on this, and this is a safety switch, a float switch, and when this float switch rises, it cuts the power off, 24 volts. So if you ever have a blank thermostat because it doesn't have batteries, make sure you check the drain. So because you can see this comes up here, and I guarantee you it breaks the R, the red going to the thermostat. You can see, well, if I can get this big old bundle of wires out here, you can see that? One wire goes to the red, which goes to the transformer, and the other wire, the other black, you can see it right here, goes to the thermostat wires that go to the thermostat. So that's how they've got that wired. So yeah, looks like 10 kW. We got 2 heaters, 5K a piece. So those are the limit. Oh, those are the limit switches. And this is the wire coming in. Looks like number 6 wire. So got a 60 amps for this furnace here. And I also have TXVs go bad. And the best way to replace this type of TXV, there is a screw. You can see that screw right there. And it's strapped around the distributor tube. And then there's the bulb. The best way to change this is there are some screws you can take out. And they are here and here or right here. And then you can take this coil, you can take this bracket off too. There's a bracket. Hold on, let me show you real quick. So there's part of the bracket right here. You can take this whole entire bracket out and you can move this coil down so you have more room to replace this TXV. Some would think you can't replace that TXV. You can. I did one last week. So I'm pretty sure, I bet you this indoor coil is our problem. Of course, there's no water because it's been in the heat mode. So, but I bet you there'd be oil in here if there was water. I think I'm gonna get my leak detector out, do a little once over and check it. I already checked the condensing section. We don't have any issues. What else can go bad? You got a fuse in here. Could have a short. Check your condensing unit first. Could have a bad thermostat. All right, let me get my leak detector. Got the leak detector. I'm just gonna go all over this coil. Check and see if I can find any nice spots. The best way is with nitrogen, though. Guaranteed. Nitrogen. But here is the leak detector that I'm using. Let me know what you prefer. Take the top off, look inside, make sure you don't see any oil, any residue, any streaks down the coil. Looks like we don't have any. Make sure there's no wires touching. And also check your service valves, because these can leak as well. So you may have to replace those. Okay. No leak found right now with the leak detector or visually, so I'm going to bring back some nitrogen. I'm going to pump the refrigerant down into the outdoor unit, and then I'm going to pressure test the indoor coil first. And if I don't find it there, then I will probably recover the refrigerant and I'll pressure test the outdoor section so I can try to find that leak. I'm going to talk a little bit about the components of the outdoor unit, and then I'm going to probably end this video. Just in case you needed to know what scales I use, Fieldpiece SR47 Job Link scale. They're really nice. So, outdoor unit. This is a heat pump, so we've got a defrost board. DFT means defrost thermostat. If you don't know how to test a defrost thermostat, I'll put a link in the description. If you don't know how to find out if a defrost board's bad, I will put that in the link in the description as well. Got a dual capacitor, got a 2-pole contactor, and that's about it for this equipment. Pretty easy, and it's got a couple pressure switches, low pressure and high pressure. If you don't know how to read schematics, you need to learn. There's the low pressure switch, that's the defrost temperature switch, and the high pressure switch. They're all in series with the call for Y. That low voltage wiring goes to one side of the contactor coil. See that? C-O-N-T, that means contactor coil. We got a common and a yellow, and that's what energizes that coil. And then we've got a defrost relay. Right there's the coil of the defrost relay. Defrost thermostat. So, pretty simple. Crankcase heater, contactor, compressor. We don't have a potential relay or a start capacitor. We've only got a dual capacitor. So you see where it says HCF cap? That's what we've got. There's our compressor, COMP. A little bit of reading on that schematic for you. And we've also got heating check chart for use with units using R410A. So this chart is very useful for charging. We've got a 024 unit. We got about a 70-degree indoor dry bulb. It was 72. If we scroll over, it's about 30 degrees outside today. So if we scroll down and we go look at this column, our high side pressure should be about 300 and our suction pressure should be about 82. And you can see we had about 60 and 325. So we're a little bit off, but these charts are great. Definitely utilize this chart. Make sure that it is for heating or cooling. It says heating check chart. For use with units using 410A refrigerant, field operating pressure, charging table, fixed restrictor, high pressure at vapor valve, suction pressure at suction service port. So make sure you know how to hook up your gauges correctly too. But that's pretty close to what we had. So nice. On these apartment buildings, you can see there's a drain right there that exits the building, the exterior, and there's a drain right here. And you can see on all these apartment buildings, there's a drain, right? You can take a shot vac if you ever have a drain stopped up and put it on the end there, and then boom, unstop that drain, get the clog out. If you ever have to replace a unit in one of these apartment buildings, they take a specific air handler. Usually it's a very short air handler, and they all look like this. They've got an opening where the filter goes. Make sure you have an air handler that will fit. And it looks like this one's hung on a bracket right there. So make sure it will fit. Line sets come out the top, because sometimes you get the wrong air handler. You get a very long air handler, and some of these apartments it won't fit, because some of them they put the water heater right below it. And you can see this. Whoa, look at that silicone. Man, somebody put some silicone on there. Look at that. That's a special. And you can see there's been some water damage. So this drain has definitely been stopped up in the past. So you can see somebody's put a rescue motor on here. Outdoor fan motors go bad, so make sure that if you're going to take the top off to check for leaks, that you check the motor bearings. Make sure the bearings are good, or If they have slack, then you may need to go ahead and order a motor. If you're going to work on these types of apartments, the parts that you may need to carry with you is definitely refrigerant. You'll need 410A refrigerant for sure. Most of these units, they're slightly newer, so they all take 410A. You'll need dual capacitors, 35.5, usually what I see. You'll need a single sequencer. I usually don't see double sequencers, but single sequencer is what I see. And you may need a universal rescue motor. You may need an outdoor fan. You may need an indoor fan if you want to put a universal fan in place of that X13. Quick Swap Products has a pretty good product to take an X13 and then to swap it with a PSC, so you may need to carry that product with you. Usually I just order the part I need. If it's an X13 motor that's out, they're going to wait. I'm going to get a part. It's usually only going to take 2 days. It doesn't take that long unless they're out of stock at the distributor supply house. But I think that's it. Dual capacitor, single sequencer, a contactor, refrigerant 410A, and a universal rescue motor for the outdoor fan just in case. Okay. If you gotta pee and you're on the job and you really gotta go, I'm gonna show you the best place to pee, okay? Right here in that corner. Who did that? Hope you enjoyed today's video. Hope you learned something. Let me know in the comments if you did learn something, what it was. If you have a question, remember, questions can become content. I do look at your questions, and if I think it'd be a good video idea, I definitely do that video. I make that happen. If you're a member and you have a specific question and you want me to do a members only videos, I will definitely make that happen. So remember that, all of my members. If you have not seen my playlist, HVAC Tips for Technicians, go check it out. There's a bunch of videos on there of live in the field experience to make you a better technician. I've got a few videos for you I dropped down there, like how to find a refrigerant leak, how to test a defrost thermostat. So I've got those for you. If you need help with your project, you need tech support, you're stuck and you can't figure out something like how to size equipment or ductwork or lay out the ductwork, I've got a bunch of videos on my members only videos playlist, like how to size ductwork, geothermal training, mini split sizing, how to size equipment, how to install ductwork. So go check out those videos. If you're a member level 3, you have access to that. If you want my email, click the join button, become a member. I'll give you my email for level 1. Only $2, and you get my email, and then you can have a direct way to interact with me so that I can help you with your problem. If you need my phone number, level 4 member access, you can have my phone number. You can call me on the phone and I can help you to start your business, to figure out what you should do if you're looking to be a technician, just to fast track your way to learn more about what it is to be inside the HVAC industry and to try to make it a career for you. Definitely hit that like button, subscribe, and smash that bell, ding, so you know what I'm doing. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.